Hello everyone. This week we're going to talk about the effect of oxygen on comic books. And when we say oxygen, we mean molecular oxygen O2, not O and not O3, which is ozone. So that's what we mean. And there is considerable evidence to show that atmospheric regular oxygen can contribute really greatly to the deterioration of paper in general, especially cheap, not well-made paper like comic books. And especially much of the research was done on photographic film, honestly, so most of it's from the late 20th century. There have been lots of methods to analyze this. One is chemoluminescence, which we'll talk about later today. But it seems to be that what they call the auto-oxidation of paper through the organic peroxides that naturally develop, and we'll talk about how that happens. And that destroys paper. And remember that that DP factor, the degree of polymerization factor that we talked about before. Well, that's affected by it greatly. There are free radical chain mechanisms that occur, and they're catalyzed by the presence of metals, particularly iron and copper, left over from paper pulping. And it can really increase how fast that happens depending on the paper and how it's treated. And of course, it also depends on the pH, or the level of acidity, and the oxygen. So all these things come into play. Which is why I put EDTA in some of my cleaning compounds to help remove. It helps remove some of these metals. And why you really don't want to use, why I try to not use peroxide when I'm cleaning my books, it's the same reason. The auto-oxidation of cellulose, and sorry, I'm reading some of my notes here, is also catalyzed by copper 2 and copper 2 plus and iron 3 plus, which we'll find out is, but more so by the lower groups. It's more oxidized by copper 1, which is faster by copper 1, and by iron 2, which are the lower oxidation states. So if you remember from any classes you may have had before, you may remember that the copper 2 is called cupric ion, and copper 1 is called the cuprous ion, and iron 3 is called the ferric, and iron 2 is called the ferrous ion. I don't know if I should be writing that out for you or not, but I can. So it's, well, I don't know if you care about it too much, but this is copper, this is the cupric, cuprous, and this part is the ferrous. It appears that the lower oxidation states, these guys here, are this occurs much faster in the presence of those than it does in their higher oxidative states. I do not know why that's the case. So these are introduced naturally in the pulping process of paper. These are just things that are just in the paper itself, and they need to be removed when you're making it. Otherwise, they will catalyze it. Accelerated aging tests that were performed at 90 degrees Celsius and at different degrees of relative humidity have shown a really, what they call a direct linear relationship, meaning that more metal, more bad, like this. And the aging of paper, as in this case, this was measured by the yellowing of the paper and by the brittleness, not the degree of polymerization or the chemoluminescence, which is another study we'll be talking about soon. The contribution of atmospheric oxygen to the overall deterioration of paper decreases markedly as the temperature is lowered, so higher temperature makes it worse, which makes sense. As a result, the acid-catalyzed hydrolysis of cellulose remains dominant factor in deterioration paper at room temperature. So acid's worse, but oxygen makes it worse. Even still, it adds to the problem. So we will talk a little bit more about that next. Now I'm going to review some of this information from this paper about the role of transition metals in oxidative degradation of cellulose. It's from 2007. I believe there was a data update in 2010. It reads, the role of transition metals in oxidative degradation of cellulose has been studied. Degradation experiments with model papers and studies of hydroxyl radical production in solution have been performed with iron, copper, manganese, cobalt, chromium, nickel, and zinc. Rates of production of hydroxyl radicals in solution have been estimated using the following scavenger, blah, 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 blah. Basically, they're just saying how they measured it. Experiments provide strong evidence that the role of transition metals during oxidative degradation of cellulose is catalytic, meaning that it just makes it go real fast without being consumed. A correlation between the behavior of transition metals in solution and paper was established at low contents in transition metal and paper. So let's go through this a little bit. So some things you need to know, I'm not going to read you the whole paper, is that you need to know this Fenton reaction. This is basically how they all go. This is peroxide, hydrogen peroxide, and this is iron. This is, remember, this is the lower state of the iron. It gets oxidized up to iron 3, produces an OH minus, and this what they call a hydroxyl radical. All right, so this occurs. The resulting oxidative species is supposed to be hydroxyl radical, although some authors argue that iron 4 might be the actual oxidant. Who cares? Rate of production of hydroxyl radicals is characteristic of the metal. In addition, it depends on whether the metal ion is in chelated form, meaning that something is holding the metal. Its chela means claw. It's been shown that the production of oxidizing species by chelated iron atoms in cellulosic matrix depends on the identity of a complexing agent. Yeah, no doubt. So, meaning that if the iron is complex, then it won't happen as much. Let me pause this for a second. I think my dog wants out. For just 1 second. So if we look at this paper overall, they measured the degree of polymerization, which is basically how long the chains get, which we know that as they get polymerized, they get less flexible, and that's something that they measured over time. And they talk about how they did the test at 80 degrees C, 65% relative humidity, and some of them they added calcium carbonate or magnesium carbonate to help neutralize the acid to control the pH, so they could understand the compounding effects. And the samples containing calcium carbonate, NPG, which is neopentyl glycol. It's like a sizing type of agent that they use to help keep the paper flat and sort of protect it. Normally, and copper chloride, where they put these things on it and then subjected it to accelerated degradation. And they monitored the reflectance with chemoluminescence at 460 nanometers. And they say here, for the reaction to take place, the transition metal needs to be in the reduced form. And this is copper 1 and iron 2, as we mentioned before. The most probable reducing species in cellulose, especially degraded cellulose, would be aldehydes, e.g. glucose. They are known to effectively reduce copper, and this is the basis of the copper number determination in pulp chemistry. So they're saying that the metals are usually in the reduced form as they listen, which is another reason I like to use ozone to oxidize the whole page, is to keep these metals in a higher oxidation state. So a lot of my books that I'm going to store for a long time, I will actually treat with ozone to keep those metals oxidized, and I will wipe them and try to remove them with a slurry of magnesium carbonate, sodium hydroxide, and EDTA, which will help to preserve the paper. I find it really works, honestly. So they talk about just the redox potential and why it happens, and I don't really know why they talk about all that stuff. It doesn't really make much of a difference, but they do have some good information here that says that the copper is the biggest culprit for if you want the aging. The iron is a little bit, but unfortunately there's a lot of copper in cheaper wood pulps, especially. And then we read here that heating of cellulose in oxidative atmosphere leads to accumulation of hyperoxides, okay, which occurs fairly rapidly. So when you're pressing your books, think about that. And when you're leaving them, but it's in that short order of time, I'm not that concerned about it as I am as much about, where they're stored in your house over long periods of time. At 80 degrees Celsius, the steady state achieved is 60 minutes, and the content of superoxides has been shown to be low. So less than an hour, it's not that big of a deal, basically. And they talk about the effects of if you add magnesium and calcium carbonate to adjust the pH, how much difference does it make? And universally adding magnesium carbonate to the paper reduces the reaction rate, like a lot, super lot. And let's see here. It reads that the cellulose samples containing calcium, magnesium carbonate differ in initial pH. Of course they do. Higher pH leads to decrease in catalytic activity, which these would bring the pH up, right? And helps sort of neutralize any acids. It says, it noticed already that in 1964 that the extent of degradation of cellulose during oxygen bleaching is decreased in the presence of magnesium carbonate. Yep, that all makes sense. If you can treat your pages with some of these slurries and keep them out, which is why one of the reasons you want to use DI water is so because your water will have some of the things in it that could contribute to the acidification of your paper, like and oxidation. So you don't want to do that. It's one of the reasons when we clean, we just don't want to introduce these problems if we don't already have them. So they just say, hey, the conclusion is it goes a lot faster with metals in it in the reduced state of metal, and better to not have them in there. So, and here, one of the important things I think is copper is by far more catalytically active than any other transition metal studied. They studied iron, cobalt, chromium are also potentially corrosive, but not as bad as copper. Non-metal specific treatment is needed to target transition-mediated oxidation degradation. Basically, don't get copper in it. That's what they're saying. So that's some of the role of, that's the reaction mechanism. It makes these hydroxyl radicals. In the presence, oxygen is consumed. It happens catalytically in the presence of the reduced state of iron and copper. And that's it. That is why you want to keep your books away from oxygen if you can, and why I like to keep them at a higher pH and to remove the metals if I can do it. Hope you enjoyed the video. Take care. Bye-bye.